Puzzle, our new and improved variation test for age-related macular degeneration, examines patients for variations in the epigenome. ARMD is an eye infection disease that leads to vision loss in elderly population. 8% of the current world's population are experiencing signs of ARMD. Genetic changes in and around several complement system genes, including the complement factor H gene, contributes to a person's risk of developing ARMD.
This gene provides instructions for making a protein called complement H. Complement H helps regulate a part of the body's immune response known as the complement system. ARMD causes vision loss that can start at ages 40 and 50, but become very noticeable in a person's 60s and 70s. This vision loss mostly affects central vision and is caused by the deterioration of light-sensing cells in the back of the eye.
It affects the macula, nerve cells, and eye tissue. A few symptoms are dark adaptation, scopic vision, straight lines appearing wavy, and empty areas or blind spots appearing in the center of the vision. Additionally, ARMD breaks down into two categories, wet and dry macular degeneration. Dry macular degeneration is more common and causes blurred or reduced central vision due to the thinning of the macula. It can develop into wet macular degeneration if the patient goes untreated and is caused by abnormal blood vessels that leak fluid.
Approximately 30 genes contribute to ARMD. As the combination of genetic predisposition and environmental factors, AMD genetic variants contribute to approximately 70% of its risk.
CFH gene provides instructions for making a protein called complement factor H, which helps regulate a part of the body's immune system response referred to as the complement system.
The current 23andMe test for ARMD tests for only two SNPs, the Y402H variant in the CFH gene and the A69S variant in the ARMS2.
Retinal pigment epithelium cells, otherwise known as RPE cells, to investigate the impact of endogenous FH loss on RPE cell balance. This test silences CFH in human HTERT-RPE1 cells.
In our puzzle examination, it will test for a total of 30 SNPs in the 10q26 region by a saliva test. In that region, the ARMS2 gene provides instructions for making a protein whose function is unknown. One specific version is the RS11200638. This is what produces the HTRA1 protein, which regulates the availability of insulin-like growth factors. The protein expression is in the cytoplasm in several different tissues with high expression in ovarian follicle cells.
This is a SNP in the HTRA1 gene for a wet age-related macular degeneration, which can increase your risk of developing ARMD by 8.66 times its normal. It is unclear how a polymorphism in the HTRA1 gene might be related to age-related macular degeneration, but variations in the promoter region of this gene are the cause of susceptibility to ARMD.
Test only evaluates two different SNPs compared to Puzzle, which scans 30 different SNPs. One of the most important SNPs that can greatly increase the risk of developing ARMD is RS11200638. This gene can increase the risk up to 8.66 times the normal chances, which are not tested at 20.
As of today, not every SNP related to ARMD has been discovered, and many of the SNPs that affect the risk are not thoroughly understood.
If an individual were to test positive, studies suggest that effective annual treatments are available ranging from $84 to $766. While financial losses can be a burden to many individuals, there are important personal implications to consider. An ARMD positive individual would be worried about their family members who are potentially at risk. Additionally, this test can be a deciding factor on whether or not a patient has children.
Breaking down your genetics one piece at a time, we hope you consider the puzzle experience to discover more about your genetics.